Hello, this is question 1 from the step 3 paper from 2022. So let C1 be the curve given by these parametric equations. X is ct, y is c over t, c is greater than 0, t is not equal to 0, which is what we'd expect with that y coordinate. Then let C2 be this circle, fairly standard looking circle at centre AB, radius r. They intersect at 4 points, P, 1, 2, 3, 4. And the corresponding values of the parameter t at these points are t, 1, 2, 3, 4. Part 1, show that ti are the roots of that equation. So this is just a, b, c's, t's and r's. So got rid of x and y essentially. So we're just taking these and putting them in there to get rid of x and y. So that should be an easy enough starter. So I'm going to have, what have I got? I've got ct minus a all squared plus c over t minus b all squared equals r squared. Right, so I'll multiply everything by t squared because then I've got no fractions, and then just expand out these brackets. So I'm going to have t squared, c squared, t squared plus a squared minus 2act. And then I'll have in here, I've already dealt with the t squared, so I'll have a c squared, I'll have a b squared t squared, and then I'll have a minus 2bct will be r squared t squared. Right, so now I just need to collect everything together. So what have I got for t to the 4 is just that term there. So c squared t to the 4. So that's looking good starter. C cubed's got to come from that first bracket as well. So it's just going to be this one, minus 2act cubed. Then the preempting that plus in the answer. For t squared, so I've got an a squared, I've got a b squared, and I've got a minus r squared. A squared plus b squared minus r squared, t squared. So for the t's, it's just that, minus 2bct, and then that leaves me with that c squared is equal to 0. So quick opener. I doubt they'll give us very much for that, but still quick opener nonetheless. Part 2, show that this thing, the sum of the squares of those t values is equal to that. Right, well, if they're our roots, I suppose we're just going in for a comparison then between what we've worked out here and if we factorise it. So t minus t1, t minus t2, t minus t3, and t minus t4. That's got to be equal to 0. But if we're going to get it to look like the thing that we've shown in part 1, we need a c squared there. Otherwise, we don't get the right coefficient on our t to the 4 term. So we've got that. Now I can compare coefficients on the other terms. So the c squared that I'm getting at the end, so the t to the 0 coefficient, that's going to be c squared times t1, t2, t3, t4. All the minus signs are going to cancel. So t1 times t2 times t3 times t4 is going to be equal to 1. So that's a start. If I'm going to get t's, so I can take a t from any one of the brackets, which means I'm going to get the other 3 ones multiplied together. So I'm going to get every permutation of 3 ti's. And I can cancel minus signs because I've got a minus sign here. So that will be t1, t2, t3. And well, I'm going to have 4 of them, because I'm leaving out t4 there. Then I can leave out t3. Then I can leave out t2. Then I can leave out t1. So that's all of those, and that's got to be 2bc divided by c squared, so 2b over c. Right, now I've got the biggie then of what's going to end up equaling a squared plus b squared minus r squared over c squared. That is going to be for t squared, so that's every permutation of 2, every 2 paired I've got there. So that will be t1 t2 plus t1 t3 plus t1 t4 plus t2 t3 plus t2 t4 plus t3 t4. Right, so that's done that one. And then the last one for t cubes, I'm just going to be getting a t1, a t2, a t3, and a t4. And again, I can cancel minus signs. So I've got t1 plus t2 plus t3 plus t4 is going to be 2ac over c squared. So 2a over c. And I want to get off of this, let's go back to red actually so I don't get mixed up. I want to do t1 squared plus t2 squared plus t3 squared plus t4 squared, which looks a bit like the last one I've just written out in blue, but I would have to take off. So if I squared this thing, I would get all those t1, t2, t3, t4 all squared, but I'd also get a t1, t2, a t1, t3, a t1, t4, and so on as I go through all of those permutations. And I'm going to get double of each one of those pairs, aren't I? Because then when I do t2, I'll get a t2, t1 to go in my t1, t2. So I'm going to have two lots of this thing, which I need to take off. So that is going to be equal to a 2a, well, I'm squaring that, so 4a squared over c squared minus two lots of a squared plus b squared minus r squared over c squared. Okay, so I've got a 4a squared minus a 2a squared, and then I'm flipping the signs on the others. So that is going to be 2 over c squared. In fact, I mean, it's exactly what they've got in the answer. So that's dropped out quite nicely. Right, find a similar expression for 1 over 1 over t squared, adding them up. Right, so if I was going to do that again and have 1 over, so if I had 1 over t1 squared plus 1 over t2 squared plus 1 over t3 squared plus 1 over t4 squared. So I need to multiply by all of those. So I'm going to have 3 of them squared together. So it's going to be a bit like squaring this thing on the top. And at the bottom, I'm going to have t1, t2, t3, t4 all multiplied together and squared. So that's just 1. Okay, so I can ignore the denominator because it's turning into this thing. So I now want to square this. And what happens when I square that? I'm going to get the terms I want, but what I want to take off is going to look so much worse. It's going to look so much worse. I'm going to have 2 lots of everything again, but I'd have a t1. So there's one thing missing in each one. It's a different one each time. So I'm going to have one set of t1, 2, 3, 4 in each one. So if I've multiplied, say, that one and that one, I got 2 1s, 2 2s, and then a 3 and a 4. So essentially that's leaving me with a 1 times a 2, because 1, 2, 3, 4 multiplied together to give 1. And then if I did that one, I'd get a, what would I get on that one? I'd get, if I multiply these two together, I'd have 2 1s, 2 4s. So essentially I'm doing t1, t4. I'm going to end up with this line again. I'm going to have that I'm taking off. I'm taking off exactly the same thing. So I'm going to have 2b over c all squared minus exactly what I took off last time. A squared plus b squared minus r squared over c squared. 2 lots of that. So that is going to be, you'd probably want to put an extra line in there in between, some kind of explanation about how you're including this line here. So you're squaring it. It's just I don't have much space on the screen here. So maybe write out the combination of these 4 fractions, showing what you've actually got, as in it's the square of all of these things, those 4 terms squared and added together. And then you can say, okay, yeah, well, I'm squaring this in total and then taking off that line. So put a line in here. I just don't have space to do it. So this means I've now, that looks exactly the same as what I had before, isn't it? That can't be right. Oh no, the A is switched to a B in the first bracket. So I've got a 4b squared taking off the 2b squared. So the b squared doesn't change sign, the other ones do. So I'm going to have a 2 over c squared. Well, it does change. So it doesn't change sign in the bracket, it changes sign overall. B squared minus A squared plus R squared. Okay, so that didn't drop out too badly, really, because there was so much sort of symmetry in what was actually going on, which makes me think there was probably a different way of going about that. Maybe there was. Yeah, I suppose we could have gone through and said, well, t is not equal to 0, so I'll divide all of this by t to the power 4, turn it into a quartic in 1 over t, and then what would that do? That would do, because this is playing on the fact that there's a symmetry in A and B. Yeah, if you turn it into a quartic in 1 over t, see, that would go away. So you end up with a c squared again, just like you've got there. But then we have a t to the 4 there, which is putting that coefficient of c squared back on the power 4 term. And then this would stay the same as a coefficient in the middle power, and then you're swapping a's and b's in those. Right, that probably would have been a more elegant way of doing it, dividing by t to the power 4 and saying, oh yeah, well, we've got the same equation with the same roots, except we've swapped a and b over. And then you can just say, well, here we go, we'll just use that and swap over a and b. So yeah, that would have been a more elegant way of doing it, actually, but I was kind of into the weeds of doing all of these equations. And it drops out fairly well when you can see what sort of pattern you're going to have when manipulating those 4 equations of roots. So anyway, it makes me feel happier that that's actually going to be right. So let's go on to a new sheet then for part 3. Hence show that the sum of OPI squared, so OPI is the distance from point P to the origin, okay, is equal to 4R squared. So that's going to come out quite easily off of these, because these are our XY coordinates. That's what's so nice about these parametrics. So we're saying then we want to do the sum from I equals 1 to 4 of x squared plus y squared. So that's going to be CTI all squared plus C over TI all squared. So I'm adding up these two things I've just worked out. So that is going to be equal to, well, let's take the c squared outside. Then I'll have 2 over c squared, a squared minus b squared plus r squared. Yeah, these a's and b's are going to cancel, aren't they? Because now I've got a b squared minus a squared plus r squared. So they all disappear. Oh, left out my 2 over c squared. That'll cancel, that'll cancel, that'll cancel. The a's and the b's will cancel, and I'm just left with 4r squared. So yeah, that came out pretty easily. Right, last part then. So yeah, flying through this. This is quite often the way, though, isn't it? The first question in these step papers is the nice one. Suppose that the curves C1 and C2 touch at 2 distinct points, right? So we've got some double roots. By considering the product of the roots, or otherwise show that the centre of circle C2 must lie on the line y equals x or y equals minus x. Right, so if the centre is sitting there, that means that we got A is equal to plus or minus B. So that's what we're working towards on this. So at least that's given us a definite target. Now, I suppose really I'm going to have to go back to all those things I've just written out on the other screen and can't see anymore. If we got double roots, it doesn't matter which ones we say are the same, because we've not made any kind of distinction between T1, 2, 3 and 4. So I'll say that T1 is T2, they're the same, and T3 and T4 are the same. So the equations I had before, I remember if I multiplied them all together, I got 1. So T1 squared times T3 squared is equal to 1. But that's going to be useful, probably, because it's going to give us a plus or minus 1 in here, and we want plus or minuses. So I've got that one, but I can't remember what the other ones are. So I'm going to pause the video and then rewrite them on here, save you watching me flicking backwards and forwards between sheets. Okay, so that's what I get by just replacing T2 and T4 with T1 and T3. So now I need stuff with just A's and B's in. So how am I going to go about doing that? This one factorizes, so let's rewrite that. as a T1, T3, T1 plus T3 is B over C. Here we go. So that is B over T1 plus T3 is A over C. So T1, T3, which is plus or minus 1, times A over C is B over C. So get rid of the C's, and then this is plus or minus 1. So I've got plus or minus A equals B, so which is the same sort of thing that I want. So there we go. I mean, that's just dropped out really quite nicely. Yeah, that was a pretty friendly question, often is, question 1. Okay, there was a bit of meat in part 2. Part 1 was borderline trivial. Part 3 was fine if you'd done part 2 correctly, but of course you'd have a bit of trouble if you hadn't. And then part 4, yeah, part 4's all right, I suppose. Well, depending if you've done this bit. If you're happy with doing that, of saying, well, we haven't made any kind of distinction between the 4 routes, so we can just pair up any 2 that we want, then the rest of it drops out okay. So it's not like the whole thing is super trivial. None of these step questions are. But overall, I would expect people would be, on average, happier with this question than most questions when it comes to step papers. So still, it's got us going on a step 3 paper.